Namaste everyone, and welcome to our channel. Today, we are going to dive into a very important topic for building high-performance Java applications, Redis caching with Spring Boot. Have you ever wondered how big websites handle millions of requests without slowing down? One of the secret ingredients is caching. We will understand what caching is, why Redis is a fantastic choice for it, and how easily Spring Boot helps us integrate it into our applications. By the end of this tutorial, you will have a solid understanding of how to make your Spring Boot applications super fast using Redis. So, let us get started on this exciting journey. Alright, so what exactly is caching and why do we need it? Imagine your application frequently asks a database for the same information, for example, a list of products or user profiles. Each time, your application has to go all the way to the database, which can be slow and put a lot of load on the database server. Caching is like having a super fast temporary storage, a shortcut, where you keep frequently accessed data. So, the next time your application needs that data, it first checks this fast storage, the cache. If the data is there, it retrieves it instantly without bothering the database. This makes your application much faster and reduces database load. Redis, which stands for Remote Dictionary Server, is an open-source, in-memory data structure store used as a database, cache, and message broker. It is incredibly fast because it stores data primarily in random access memory. It is a key-value store, meaning you store and retrieve data using simple keys. For example, you can set a value like setUser 123 John Doe and get it back with getUser 123, super simple and super fast. Now that we understand the why and what of Redis, let us see how we set up Spring Boot to work with it. Spring Boot makes integration incredibly easy. First, we need to add a couple of dependencies to our pom.xml file. We will need Spring Boot Starter Data Redis to connect to Redis and Spring Boot Starter Cache, which provides Spring's caching abstraction. Once these are added, Spring Boot will auto-configure a Redis connection for us. Next, in our application.properties file, we tell Spring Boot where our Redis server is located. We specify the spring.redis.host and spring.redis.port. Typically, Redis runs on localhost and port 6379. With these simple steps, your Spring Boot application is ready to talk to Redis and leverage its caching capabilities. It is really that straightforward, isn't it? Excellent. With our setup complete, let us see how we actually implement caching using Spring Boot's powerful annotations. The star of the show here is the @cacheable annotation. Imagine you have a service method that fetches a user from a database. By simply adding @cacheable users to this method, Spring Boot automatically handles the caching logic for you. When this method is called, Spring Boot first checks if the result for the given input parameters is already present in the user's cache. If it is found, the cached result is returned immediately, and your method is not executed at all. If not found, the method executes, its result is stored in the user's cache, and then returned. It is like magic. You can also specify a custom key using the key attribute, for example @cacheable value is equal to users key is equal to hash ID, where hash ID refers to a method parameter. This ensures that each user has a unique entry in the cache based on their identifier. Of course, data changes, right? What happens when a user's information is updated or deleted? We need a way to tell the cache to update or remove the outdated information. This is where @cacheEvict and @cacheput annotations come into play. When you update or delete an entity, you would typically use @cacheEvict. For example, a delete user method can be annotated with @cacheEvict, value is equal to users, key is equal to hash ID to remove that specific user's data from the cache. This ensures that the next time someone requests that user, it is fetched fresh from the database. On the other hand, @cacheput is used when you want to update the cache with the result of a method execution without skipping the method. For instance, an update user method can use @cacheput, value is equal to users, key is equal to hash user.id to ensure the cache always has the latest version of the user object after an update operation. These annotations give you fine-grained control over your cache data. And there you have it, my friends. We have covered the essentials of Redis caching with Spring Boot. We started by understanding the fundamental concept of caching and why it is crucial for performance. We then explored Redis as an incredibly fast, in-memory key-value store. We saw how to easily set up Spring Boot with the necessary dependencies and configuration. Most importantly, we learned how to use the powerful @cacheable annotation to fetch data from the cache, and @cacheEvict and @cacheput to manage cache updates and removals. Remember, caching is a powerful tool, but use it wisely. Always consider what data benefits most from caching, and ensure you have a proper cache invalidation strategy. Practice these concepts in your own projects. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java tutorials. Keep coding, keep learning, and I will see you in the next video. Thank you so much.